No, no, no. We're doing deprive first. And as far as I know, I'm the only deprive person.
Yep, that's the only deprive presentation.
Yeah, yeah, great. Okay.
No, we have slides, Paul. Paul, the chairs have slides.
So apparently Tim just heard all that.
Is this mic on? Oh, yeah. Hello. It's a good thing I've stopped saying bad things about you, Glenn.
Yeah, of course, Dave.
Yeah. So you do have scribes, Tim?
Yes,
No, we have slides. We have two slides that go before
and are
Paul.
they willing to cover our ADD portion as well?
No, slides, not scribes.
Oh, slides.
Yes.
You need a better mic, man.
Well, Dave, let me.
Yeah, I think I'm going to have to let Brian drive the slides.
This is some kind of West Virginia problem, isn't it?
Don't go there. Come on, David. It's early for Tim.
Yeah. So I guess I really do not want to have to resort to the crying. I am an ugly crier. Who will be our scribes, please? That word with a C, scribe, not slide. Oh, Lord. Oh, thank you so much. You were very kind. I appreciate it very much. Yeah. Right. So you have presenter. Grant yourself presenter, right? Yeah.
I'm presenting.
Right.
Yeah, presenting, right? The slides.
Yeah, it's not. Turn on the presenting. Go up. Yeah. Share screen.
I'm not sure my screen. I'm sharing other things.
Right.
So that's coming out of there.
Right. And then when you click on go to the meeting materials, right?
Oh, that's right here.
Yeah. And then.
And so I successfully got that up.
Right.
It's lucky, but how do I interact with the control one?
Right.
Hi.
Hi.
Yeah.
Can you help Glenn?
Stupid question. This is up. It's running. Should we
So you have to, I think, select the one. Go ahead.
Because it's actually showing the right slide,
It doesn't look like it's full screen though, does it?
but I don't know how to interact with the slide control. Would it be easier to do it on that device?
We cannot use that device.
All
That
right.
one's, do you mind if I
Go ahead.
That's just for monitoring the queue.
say, this is the one you wanted?
No,
Well, the
so
agenda
share slides right here.
again.
And I got them to show up there on the screen. They're coming through properly.
Dave, do you not have the slides showing in the room?
Yep, they're showing the room. It's just the
window with control.
Yeah, but it's not as the thing. It's just showing the Meet Echo window.
Yeah, it didn't give any like controller face to interact with that. I know that's what it did. Like, there.
Oh,
Sure.
presentation view. There we go.
There you go.
Thank you.
That's the reason why
Hello.
I'm doing AD, right?
Yeah.
It's only to click on the right button.
The AD came to the rescue. Thank you, Eric. You're awesome.
This is why he's taking.
Okay, I guess I failed the audition. Okay.
I wasn't much help.
So, are we going to be having a local deprive chair?
No.
No, Dave and Glenn, if you guys just want to cover the administrivia, I will cover slides 5 through 8, and then we'll hand it off to Paul.
All right. So so the way this is set up is we're doing shared slot. Deprive is going to go first, and then ADD. We have slide sets for both of them, and so I guess Tim is going to remotely run the agenda for that, and I'll manage the slides. So of course, NoteWell applies to this. It's an IETF meeting, and we are all subject to NoteWell. Please read it and be familiar with it, especially BCP 79. That's the best. IETF meeting tips. This session is being recorded, so please be aware. You're also required to wear masks in the room unless actively speaking at the microphone. And Jim Reed is wearing a mask. There's additional resources for IETF 115 Monday. You've already seen this probably in other sessions. And then deprive, I'm told, has a couple of slides they're going to show.
I would like to acknowledge first that Limon has volunteered to be our scribe. Thank you, Limon.
Thank you. So, Tim, I guess you're in charge here.
I'm going to do it, Glenn.
Oh, okay. Sorry, I can't see anybody. I just hear voices.
That's fine. Hi, everyone. This is Brian Haberman. Quick update from the deprived chair's perspective. Paul will talk a little bit more about the unilateral probing draft, but the big thing that we wanted to push across is we're really starting to look for more implementations of it. Currently, the only one that we're aware of is the Power DNS. So, thanks to Peter. Tim and I have been chatting about this, and we have a couple of thoughts about what we should do going forward. Next slide, please. So, similar to what you see in the routing area, with the potential impact of some of these changes, we were wondering if it actually makes sense for us to either park the document while we wait for more implementations, or potentially do the working group last call on the document to then park it and wait for more implementations, so that we're sure that what we put forth to the IESG for submission as an RFC is as stable and as well defined as possible. So with that, next slide. I'm just curious if anybody has any comments or thoughts on that approach, especially on the waiting on implementations, or the state at which we want to park it if we do want to wait for implementations.
And I'll just add, I'm going to assume that deprive as well. We're going to use the meeting tool for doing queue selection. So you've probably seen this in the other working groups already this week, but please use that so that the scribes can see who is making comments and going up.
Ben. Yeah. Okay. Yes, Ben, please.
Hi, Ben Schwartz. I work at Alphabet. I do not work for the most part, on Google Public DNS. I think the people who do are probably in the room. But, I think that Google Public DNS is headed toward an implementation of something along these lines, but it probably won't be precisely what's in the RFC. And I suspect that that's true of essentially many large-scale resolver systems, which are not going to take the sort of parameters and state machine directly out of the draft, but are going to internalize the ideas and write their own similar kind of functionality. So I think that if you want to talk about interoperability, given that this isn't really a specific protocol so much as a general family of behaviors, I think that's a subtle question. But I do think that it's happening.
I was just going to ask Ben, would Puneet be a good person to talk to about
I
that?
see Victor behind me in the queue.
Okay.
He's better positioned to talk about that.
Yes, go ahead, Victor.
So yes, we are doing probing of some form, whether it's by the draft or not. One of the things that I think might be good to hear from other implementations is questions around timing. I see a lot of authoritative server implementations, even under light loads, closing connections early, after a small number of queries or after a small time has passed. And this creates complications for implementations. There are probably other issues that other implementers will discover and complain about and so on. So it may be worthwhile to have more implementation experience.
Great. Thank you both, Ben and Victor. And it's back to you, Brian.
All right. Thanks, guys. And I appreciate the input. The things that we want to figure out, and Tim and I will take this to the mailing list to make sure that we get everybody's input on it, is making sure that what does get specified is as clear as possible and as functional as possible. So with that, I think we'll turn it over to Paul for his presentation.
Yeah. You're unilateral probing, right?
Correct.
Yeah.
I'm one of unilateral probings.
Yeah. It's not in presentation just yet. So. Yeah.
No.
Right.
No.
Because
it's the other chairs.
Right.
And they were asking for thoughts. And pretty much it sounds like, from what Brian said, they need to think more and ask more.
Paul's an honorary chair.
No, I'm a concerned co-author.
Yeah. It right.
I didn't make the mistake I did in DNSOF, which is you can't put numbers at the end of your file names.
No, it should be.
One of you accepted it.
Oh, there you go. Yeah, yeah.
It's stupid driver problem.
Yeah. Yep, that's the one. Share and then presentation.
Perfect.
View.
Okay. So this is going to be quick, not QUIC. This is going to be fast. This is just really the status of where we're at. This is not to cause discussion here. This is really talking about status. The discussion on the mailing list is going to be infinitely more valuable than anything here, simply because, as we heard just from the chairs, they're trying to get more going. And so on the list would be best. Next slide. I'm giving the presentation. Joey's back there. I only asked her 7 times to give the presentation. But so for those of you who are only following DPRIVE, meeting to meeting, what has happened since the last meeting was that Puneet Sood from Google Public DNS sent a nice lengthy list of suggestions and questions to the mailing list. We responded. We didn't do everything he asked, but we responded to everything, and we did a bunch of the stuff that he asked and put out a significantly revised draft. Nothing technical changed, I believe, but in fact, there was a bunch more there. And referencing what Brian was just saying, we want to know what implementers and potential implementers, I was like, I don't need to wear that at the moment. We want to know what implementers and potential implementers are not finding in the draft. What we're sure of is that once this is deployed and there's 2 more implementers out there, there's going to be implementation experience. What we want is the draft ready to go to working group last call with as much as we can know in that state. So we asked for more, after we put out the last draft, we asked for more comments on the mailing list, and we only heard crickets. Now, this is most likely because the only people who actually need to care about this draft are resolver implementers. It turns out that authoritative implementers don't need to do anything in the draft. The whole section on suggestions for authoritative implementers, there's only one thing that you might want to do, and you'll either do it or not. Everything else is, we suggest you look at this and you watch out for that. It's the recursive implementers. So there aren't that many of them out there. Some of the people from those recursive implementations are in the room. I don't think Puneet's actually in the room, and Victor is off. So as Brian said on his slides, we know that Power DNS Recursor has done an implementation. They've talked about it a bit. We'd love to hear more if there's anything else in there, but that's where we're at now. This is what's happened since the last meeting. Next slide. So we'd like to tell you what our next steps are with timing so that you can figure out when you want to review it, since we asked you to review it earlier and almost no one has. There are some open issues. There's a few open issues that we have on the GitHub repo. Within a month, we're going to close them out. We're going to do them or close them. Sarah, I'm going to point at you right through the camera there. We're not sure if we've done what you asked for eons ago. We think we might have, but if you have time in the next month, can you check our work? Sarah gives a thumbs up. Any other implementers who are reading this, or people who are not implementers but think they know how it is to make a recursive implementation, please review the draft. Like Brian said, We aren't saying you must do this, you can't do this, as much as you really should do this and such like that. Please check our work. So we'll have a new draft in about a month. We'll turn it in, and then we're going to ask for more discussion on the mailing list. And then we were going to ask for a working group last call in January. As Brian just indicated, we don't know whether it's a working group last call that will then fling this towards the IETF or be parked or whatever. I think we could get enough implementation experience by then if some of the implementers, even the ones who haven't implemented but looked at the pseudocode and said, oh, I can do that, I can't do that. It would be great so that start of the year we can go ahead. Next slide. Brilliant.
Yeah, that was all your slides.
I know, I'm sorry, that was a bit of drama. Sorry.
Would you like to talk to Victor now then?
Certainly. So Victor?
The note is that authoritative server operators are also implementers when they turn it on. And we're beginning to hear back from some of them, you know, wanting to tune things with us and so on. So I think there's room to invite authoritative server operators to also talk about their experience in terms of scaling or various other things, or what they would like to see from resolver behavior, which are the kind of questions that
fair
come back
point.
to us.
Some of the, even though the document doesn't say, here's what resolver operators, here's what authoritative operators should do. Some of them have been testing, especially with the Power DNS implementation. They may have come up with something, and that may be an addition to this or not. We're trying to be, again, the whole idea is this is unilateral probing. We're trying to be as unprescriptive as we can to make a system that works and doesn't fail anybody. That's a funny balance, but I think we're pretty much already there, but we need to hear more. Is that it for the queue?
Yeah, that was
Okay.
it. Thank you.
So great. If you want to read now, please read now. If not, please plan on reading in December. A lot of people don't like to read in December. So if you'd rather read in November, please do now. Let us know. Thank you.
Lot of eggnog helps. Thank you, Paul. Thank you, Victor. And thank you in advance, Sarah. Brian, did you have more?
No, Glenn and Dean, I think that's it for the deprived session. So unless folks have other comments they want to make, I will turn it over to you guys for ADD.
Thank you, sir.
Thank you.
Well, welcome to ADD at IETF115. I'm Glenn D. Well, I'll brief that.
Hey, look,
This is an IETF meeting, so note well does apply. And if you haven't heard of BCP 79, it's awesome. IETF 115 meeting tips is being recorded, just like the previous session was. These resources. I will remind you that because this is an IETF meeting, for those who just joined the room, we are required to wear masks in here. So please mask up unless actively speaking at the microphone. I'm Glenn Dean. I'm one of your ADD co-chairs.
Hi, Dave Lawrence. And our trusty scribe, Lehman.
Mr. Eric is our illustrious, awesome, best area director I've ever had this week. So we've selected the scribe. We've welcomed the chairs. Any comments from the AD, Eric, that you'd like to make? Yeah. And that way you'll also be on camera.
I'm so used to being at the mic line. So the main comment I have is about the document, the three documents that has been approved by the ISG, the DNA, the ADD, and the SVCB. They are approved. They are into the RSC editor queue, waiting for DNS up document, which is also approved, waiting into the RSC editor queue for a TLS encrypted SNI or ECH hello, which is still not in working group last call as far as I know. So we can expect those documents waiting a lot. We are trying to find inventive way and making some kind of process engineering, most probably to remove part of the DNS ops blocking. And then if we remove DNS op blocking, DNS ops progress, and then our 3 ADD documents will be going forward and will be published. So it's basically outside of our control.
Thank you, Eric. Okay, so let's get on to the drafts. The first one, Tiru, you want to come on up?
Well, did you want to agenda bash though? Because
Oh, do we want agenda bash? Does anybody want to add anything to this agenda?
Hi, Thiru here. I wanted to discuss a draft that was created by us to address some of the discussions that were raised during the publication as part of ISEC review. Paul and a few others had raised comments, and we wrote a draft specifically for that. If you have time, we would like to discuss that.
Well, we're running good on time, so I don't see any problem with that. So let's do that.
Yeah, thanks.
We'll add that in. Okay. Onto the drafts that were scheduled, and we'll get to the other one at the end. The very first one was your split horizon DNS configuration draft. So let me bring that up. And just let me know when you want to jump.
Yeah, thanks. So this is mainly the changes we have done to address comments from the working group. Next slide, please. So the two main comments were to use DDR for local DNS authority and to fix up the scope section, especially as a domain name. So we did both the updates, and I will walk through the changes that we have done. Next slide, please. So in the previous versions of the draft, the scope was restricted to just using DNR. Then Tommy Pauly had come up with a comment that we could leverage this draft even when DDR is present, and we updated the draft so that we can use DDR both in verified discovery and opportunity discovery modes. So if you look at this figure, even though IP address is used to discover and validate the discovered certificate, if the subject alt name extension within the certificate has the name server records that you would later find by doing a DNS query, either using an external resolver or DNSSEC, and if they both match, then it proves that the discovered encrypted resolver is an hybrid resolver, which is authentic to provide responses for these split horizon domains. And in that way, DDR can also be used similar to the way DNR is being used. That's first part of the change. The second part was, next slide, please. Yeah, the next slide was with regard to opportunistic discovery. In opportunistic discovery, there are two modes basically, where the client does validation of the PKI certificate, or it basically skips and does not do any certificate validation. If it doesn't do any cert validation, then this mechanism is not applicable. But if it does PKI validation, and even though it is an, let's say, a private IP address that's being discovered, but if the name that you find in the subject alt name matches that what you find in the name server records, then you know that it's a successful match, and you could use DDR way of verified discovery even in the opportunistic discovery mode. Next slide. Yeah, one of the comments from Ted Lemon was we could not use the mechanisms discovered in discussed in the draft for especially as in domain names. They are not unique to any specific DNS server's authority, and they should be kept outside the scope of this draft. So we added a paragraph to say explicitly that these SUDNs are outside the scope, and added some normative text to say that SUDNs must not be validated using the two mechanisms that we have defined in this draft. Next slide. I think we have addressed all the comments received so far from the working group, and it probably looks ready for working group last call.
Okay, thank you. Thank you. And stay right there because you're up again in just a second.
Well, do we have any questions for Tiru?
Of course.
Okay, moving on to the next.
Okay, and
Yeah, I don't have the agenda in.
The resolver.
It re-up that one. Yep.
Okay.
Okay, thanks. Yeah, this is an individual draft that we have. It's been discussed in several previous ITFs, and we have been updating the draft to address the comments. Next slide, please. Yeah, the last comment, major comment that we got at the last IETF was don't use JSON encoding. It's not the right way of doing it. And the suggestion was to use key value syntax, just like the way DNSSD does. So we changed the entire draft to abandon using JSON encoding. Now it uses key value pairs. It uses test records and uses the encoding rules and verifications, very similar to what is being defined in DNS service discovery specification. Next slide. Yeah, discovering resolver information is part of the charter, and I think this is also one of the reasons this working group got created. And we would, since we have addressed all the comments and there was some traction on this draft, we think it's ready for working group adoption.
You want the appendix slides as well, or?
No, I can skip that. That was just for backup.
Okay. Do you actually, Glenn, want to get a sense right now of how people feel about working group adoption, or?
You want to do a
So,
sort of general hum, or?
well, I don't even know if we have to do that, but first, would anybody, the queue is open if anybody would like to comment on that either way. And then we can also run a quick hum on the tool as far as working group adoption. But of course, the actual official adoption call would be on the mailing list. But it would be nice to have a sense of the room, at least as far as how people are feeling. And no one's joining the queue, but Glenn is working up the poll right now, so that should be appearing in Meet Echo in just a moment. Give it just another 30 seconds or so. Yeah.
So as you can see from the results, it's kind of split.
Yeah. There is a slight bias toward adoption. It will be brought up on the list again, so that people can say explicitly if they were opposed to adoption or not. Because sometimes the do not raise hand is a little inscrutable to interpret. But so be on the lookout for a request on the list toward working group adoption on this. Thank you. Sarah.
I miss hums.
Yeah. It was so quiet.
It goes back to the very beginning. So let's just jump to the draft.
Yeah, that's it.
I love the title.
Yeah.
We have a cheat screen, love it. All right, for those who don't know me, I'm Tommy Jensen from Microsoft. John Todd from Quad9 and I wrote this proposal to handle redirection from one encrypted DNS server to another. Next slide, please. So this is normally load balancing among multiple encrypted DNS servers globally is handled by Anycast. So you can hand out one configuration to clients and then they magically end up where they need to be. However, this requires significant resources to get correct. Not that anyone has experienced any major issues with BGP missteps recently, but it has been known to happen. And so this tends to have a centralizing effect, right? Because you have to have a large enough infrastructure to do it correctly to get the benefits of Anycast. Next slide, please. Otherwise, you end up with distributing unicast configurations. And so you say, well, we have these 30 servers and the clients need to be aware of them, or we have to somehow distribute each individual config to the right client, depending on where they're at, which brings in its own complications. And then even when you do, if the client ends up in the wrong place, you have compliance or performance issues. And then for the server, it has no flexibility to shed traffic that is being overloaded with. Next slide, please. So we're looking to find a way to allow servers to redirect to one another to address those problems, such that you wouldn't need to have any cache to be able to redistribute clients to where they need to be, and still only have to distribute whatever configurations you want for your setup. We don't want to reduce the security. Like whatever new connection you end up on shouldn't be less secure than the one you started on. It shouldn't break compat. Following redirections shouldn't end up with a connection that you don't know how to support, or to a server you don't know how to support. And it should work across protocol versions. We have 3 major implementations of encrypted DNS today, and we shouldn't be doing one of these drafts for each one. And then finally, as always, let's not waste too many milliseconds. Next slide, please. So what we're proposing is a reuse of the DDR mechanism. For those who are familiar, we're going to use the resolver.arpa SUDN and just ask the server. So when you first set up your encrypted DNS connection, you send a query for resolver.arpa and ask the resolver about itself. Are you designating anyone, in this case, as a redirection and not as a companion encrypted DNS server? Note that this is slightly different from the use case that DDR covers, which is that you're already starting with encrypted DNS, which DDR mentions when you're looking up other resolvers. This is asking the resolver about itself, which DDR supports over plain text. Since we're starting with encrypted and ending with encrypted, we can go back to the traditional authentication model and we'll authenticate the name of the destination server without having to do any of the IP address tie-ins. Next slide, please. So as an example, let's say that a client is configured to use do-sydney.site.example. And then you start traveling abroad, you go to a conference, and the server sees you coming from a Paris IP and says, you really belong somewhere else. And so when the client sends the query for the a quad A and service binding, ignore that AAA, it'll send back a service binding record that says you should actually be talking to do-Paris. And the client will then establish a TLS connection to that server and check to make sure that certificate is valid for do-Paris. And when it is, we'll replace the connection and then move on with our lives happily ever after. The security model here is something that we're trusting because by using the contents of a DNS query, it's exactly as trusted as if we just stayed on this resolver in the first place. In other words, if an attacker were able to compromise this redirection, they were also compromising your query contents. Next slide, please.
Tommy, would you mind an interruption from Ben
Not at
right
all.
now?
Ben, go ahead.
No, I'll wait.
Okay. Ominous.
No pressure, man.
Yeah. So a couple considerations. So as with any other redirect, there's a potential for leading the client around. There should be some considerations that, just like CNAMEs, please don't do that. Additionally, there's a potential for breaking compat here. Let's say that the original server you start with supports dot, and you contact it over dot, and you ask it for a redirection, and it gives you one to a DO only server. It's possible that the client also supports DO, but it's possible that it doesn't. And this would be a broken scenario that would result in either the client losing encrypted DNS connectivity or deciding to just hang around on the original server, which obviously it didn't want either. And so it requires you to redirect to a server that at minimum supports the same protocol and IP family that this connection is using. Such that it knows that the client ought to be able to talk to the next one. Maybe additional information is in the service binding and it can choose to do a different protocol if it wants. That'd be great, but let's at least make sure that it can speak something. Next slide, please. All right, so there were some alternatives that we considered when designing this solution. One, when talking about redirection, there's an obvious solution in the 300 return codes, except that that's very specific to HTTP, which means that we have a DO solution and not a dot or doc solution. And so we didn't consider that ideal. The other is alt service binding. And for those of you who are unfamiliar, there's some work going on in the HTTP working group where we're introducing a DNS record that, or we're using service binding to replace alt service. Eventually, it's a strong and overloaded term, replace, but for now, augmenting. The scope of this is a little different though. That allows you at a domain name level to say, these are alternatives for me. That's not exactly what we're looking for, right? Because this is per connection behavior. It may be that I actually want that the original server wants to receive these and it doesn't want an alternative, but once every year on the day after Thanksgiving, I want to start redirecting people to other servers that I spun up that one day a year to handle all the excess traffic that I'm getting. Next slide, please. All right, so in conclusion, we believe we've identified a one-size-fits-all solution so that if the working group were to adopt this and move forward, that we would not need to revisit redirection again. This should work for all common encrypted DNS scenarios. It'll help level the playing field a little bit to help simplify and lower the bar for what it takes to deploy a multi-node DNS system across the world for smaller operators. And finally, it's always good to reuse our existing mechanisms and avoid inventing new things. Next slide, I believe is just a question slide. And I see there's 5 people in queue. This ought to be fun.
Yeah.
Let's hear it, Ben.
Let's start with Ben.
Okay. Hi. Can you hear me?
Yes.
Great.
Yes.
Okay, I think this is a great goal. I'm all for it. There's no reason that a DNS server has to live on a single IP address in this world. It sounds to me like you're assuming that you are bootstrapped from a name. You already have a trust anchor name for this service.
That's correct.
That means that to me, that suggests that we're in DDR section 5, discovery using resolver names. So the client, in order to make this connection in the first place, started from a name, did a service B query for _DNS.name, and got back its list of service bindings with different options. So at that point, we already had an opportunity to send the client out into the right node, right? Because we can serve geolocated, load balance, and optimized answers to that service B query. And it sounds like this draft is about the case where that step didn't work right, and the user ended up at the wrong place. Is that right?
So I'd say that's one narrow scenario where this applies, but it's much more general than that. So first of all, you're right. If the client got to the first server via DDR, there's probably an implementation opportunity for whoever runs the plain text resolver it bootstrapped from to have redirected them correctly in the first place. However, this is generic to wherever I got it. And so if as a user, I type in do.sydney into my Android UI, Windows UI, Chrome UI, Firefox UI, anything, and then I travel abroad, now I'm in this scenario, and the acquisition method was out of band, non-protocol based, right?
That is section 5 of DDR. Section 5 of DDR assumes a bootstrap starting point, which is a name of the service.
So section 5 is about asking for a given name. And yes, so for example, it doesn't use resolver.arpa if I'm thinking of the right section. You're asking the name itself. So you already have the name and you say, hey, server, and maybe it's the same server or not, whatever. I want to ask for records for do-sydney. The problem is I don't know anything about if you wouldn't mind reversing to the example slide so that I can refer to. You start with do-sydney. I know about do-sydney. Everything's great. I don't even know as a user or my device that do-paris exists. So when sorry, go ahead.
So I understand that that's how this is set up here, where you have distinct names for each of these entry points. But I don't see why you've set it up that way. why not just use the same name for all of the sites and use use GeoDNS essentially to serve the right IP addresses and have, so all of these various IP addresses, they're all IP addresses of do.site.example.
Sure. John, I don't know if you're on mic available, but I can already hear the IP database shortcomings argument coming.
Sure, that's one. Additionally, I would say that this also permits cross-domain repointing as well. So you can actually pass off responsibility to different operators. So in other words, you can rendezvous on one domain, but then retransfer to another. That may be good or may be bad. That's going to be site or implementation specific, but this does allow that versus having to have everything in one single database with one single lookup at the very first point of interaction.
Yeah, so it seems like the case where this makes sense is specifically that case where you're trying to do a redirection and you're trying to redirect to a server that you don't trust to speak for the same name that you started with, right? Because if you had full trust in that other server, then you could share the private keys for the certificates, and so you could share the names, and you wouldn't have any need for these distinct certificate validation names. And I want to be clear that this is not about managing a single set of a very large number of A records on a single name, because Service B provides that level of indirection where you can say, okay, you wanted to resolve _DNS.do.site.example. Here's a list of RRs. Here's Paris.site.example in the target names. Here's a bunch of different geo target names. Those don't affect the identity of the service, the security anchor. So I'm not sure I understand I think I've been kicked off of the network.
No, we can still
but,
hear you.
Yeah, okay. And Ben, we do have a long queue at the moment, so if you want to hop on the end, I want to hear from a few other people right now. So. Ted, you dropped out of the queue, but take the mic because you were next.
Yeah, I think it's because I closed my laptop when I got up, and I think it's been closed long enough. You gave up on me.
Yeah.
Ted Hardy, Cisco, also author of one of the original Anycast DNS drafts, 3258. And I think what I'm coming to ask about is similar to, although slightly different from Ben's question, which is from this slide, you start from a fact that a client is configured to use do.sydney.site to example. And because it's configured to use a specific name, later during its lifetime, when it's been geolocated by the server that it's talking to being somewhere else, the server triggers what's in essence a reconfiguration. His question was, why don't you call it by the same name? My question is, why are you driving the reconfiguration from the server side and not the client side? If you've got this set up with a client is configured to use a particular example forever, then this is a problem you have to solve at the server side. But if you've got it set up so that the client knows that it's reattaching to a new network, which is something we use to drive other things like MAC address changes for privacy, et cetera, you could use that to drive whatever the initial configuration is that it would use to find out what its appropriate server would be. That means that you're starting from the same place both times. That looks like a logical thing to do, and I didn't see it in your alternatives considered, so I'd like to know whether, one, you considered it and why you rejected it if not, and if you didn't consider it, why?
Thank you. That's a good question. So I'm also noticing, you can get into the queue if you want. I'm seeing some emphatic reactions in the crowd. So I'm going to defer to John in a moment, but this is something that we had talked about, and we're looking at operator flexibility, right? So you're correct. I mean, I work on a OS platform, right? Endpoint configuration, and doing it that way, we usually prefer to network configuration. Because like you said, this is, you could look at it that way as a reconfiguration of the device. But it's far less flexible, right? Like if I'm working for a company and we have a custom encrypted DNS fleet and we have 30 locations. Let's say we add 5 more. Do I need to go teaching all of them when and where they apply, or can I just let the system handle it? I've configured them with one, then it will do another. Now, I do think that there's a UX opportunity there, right? Maybe whether through logging or through UI or whatever else, you need to be honest about what your new endpoint is. But both with this and with the sharing names, we just didn't see that. It seems like an artificial burden to require whoever is configuring this to have to do that at the endpoint when the DNS could just handle it for you.
So this is going to be an interesting conversation in the working group if this is brought to the working group, because I completely disagree. I think it's actually far more flexible if the client does it, because the client may decide based on attachment to specific networks that it doesn't want to use this at all. It wants to go someplace completely different. And if it's getting redirected from something that's in essence hard-coded, it doesn't get that flexibility. So I think we may have a philosophical discussion we have to have here on whether it's up to the DNS to determine what your next resolver is, or up to you to reconfigure with advice from the DNS what your next resolver is. And I think the DDR actually does the advice from the DNS for the client configuration, and I don't think that's quite what you're doing.
Okay, so thank you. And it sounds like that'll be a good mailing thread discussion. As a co-author on DDR, whether it's advice or configuration, I guess could be debatable. Thank you. Regardless, let's start an email thread.
Yep, Ralph, please.
So you are asking underscore DNS resolver at ARPA, right? What would happen if the query kind of comes back to the same server? Because, I mean, then you still have to do something, or are you checking this?
So good question. It's not directly called out or accounted for, but because unlike plain text bootstrapping, DDR, the identity here is the name. If it redirects to the same name, no action should be necessary.
Tommy Pauly, please.
Hello. So thanks for sharing this. Interesting idea overall. I like that we're reusing the SVCB query.
Tommy, you're a little hard to hear. If you could get closer to your mic or something.
Sure, maybe I'm on the headphones right now. It's also raining extremely heavily up there. Can you hear me if I'm speaking up? Yeah. Okay, I'll just speak loudly. So I do see that the server may be able to give a better response when it has more information about the client. That's more direct in this TLS connection. I also do agree with Ted that we should have things be mainly driven by client network changes for handling different regions, etc. But certainly when I first join a network and I use a UDP query over the network resolver to find the location of Sydney.site.example, it may route me incorrectly due to the client subnet not being available through the UDP resolver or some other issue. And in the experience we have with our DOE and Oblivious DOE resolvers that we're using for private relay, we already do some what we call DOE bootstrapping, which is once we connect to our resolver, we ask it for its own records again to see if it has better or higher fidelity answers for us. So I'm wondering if maybe we could just do that. I think that's agreeing with what Ben was saying. Instead of doing resolver.arpa, just do the SVCB query for the original name again. So like when I join a new network, I find my resolver and then I immediately ask it for its own identity again, just to see if my local network resolver routed me slightly incorrectly.
So if I'm following, is there a significant difference other than querying for the name of the resolver you're currently using versus the SUDN? Is the behavior otherwise the same, or is there another difference I'm missing?
I mean, it should be the same thing in this case, but I think it's more consistent and more obvious to say, I know what I'm talking to. if I already knew the name, that we should just keep going with the name rather than jumping back to resolver.arpa.
Okay. Okay. So yeah, obviously we have some thinking to do. Thank you and Ben for bringing that up. I can see how that might be simpler, but I haven't had enough time to chew on that and say we haven't forgotten about something that drove our original decision. Thank you.
Yeah, right now we don't want to go too far down the design path because that's something that should happen on the list. Right.
Yes.
Yeah, but Vittorio, please.
Hi, Vittorio Bertolo, Open Exchange. I confess I didn't read the draft, so I don't know if this is already addressed, but it was not in the presentation.
Sure.
So it's, well, I see the use case. I see why you want to do this. It's a valid use case. But then, of course, from the policy viewpoint, as soon as you start switching people to a different resolver, you run into all the problems that we already discussed with DDR and DNR. And so at least this should be the subject of a robust privacy and operational consideration section. Because, I mean, if you really use this just to switch people to a resolver which is in the same jurisdiction, run by the same company and under the same policies, nothing bad happens. If you start switching people to places which have different privacy laws, or maybe apply different, I mean, maybe the other resolver is applying different policies, or is run by a different organization, and then maybe you need some kind of user consent. So we might declare that this is out of scope. We might leave this to whoever is running this to take care that everything is actually legal and in line with user expectations. Because I agree that if we assume that people actually type the DOH name, maybe they really want to, even if they are in France, they want to speak to a server in Australia, not to a server in France, which may be forced to apply French law. So, I mean, I'm fine with this, but at least this needs to be documented in the draft if we want to proceed.
Right. I might have actually a comment on that one. I would argue that this actually makes that kind of policy decision easier, because when you have an Anycast array, of course, your packets are going to go whatever is closest as far as the network is considered. This allows redirection to a unicast address, which is in the same policy zone, or the belief at least is that it's in the same policy zone as the querier. So this creates, I think, an easier way for resolver operators to segment from a policy perspective, segment their user and resolvers into the same policy zone.
Liman asked, how do we know it's unicast? But that's a whole separate thing.
Yeah.
Thank you, Vittorio. Victor, please.
Redirects mandatory, or are they just advisory and the client can keep going with the same resolver? And secondly, you mentioned multiple redirect hops. I'm very skeptical about the need and wisdom of allowing second and third and so on redirects.
So let me answer the second. I might have to have you repeat the first. The audio started cutting in halfway through. But for redirects, that's actually our point, is we don't want you doing multiple redirect chains. So if what you want to see is stronger guidance about, clients are free to start ignoring them after the first one, I'm certainly fine with that. But agreed, that's not something we're trying to encourage. We're simply calling out as advice to implementers on the operator side that you need to be mindful of that. And if you start doing things like creating circular chains, that you're going to have a bad time.
Right. The first question was whether redirects are mandatory. Do you have to follow them, or can you just stick with the resolver despite its preference to send you elsewhere?
So that's a good question. I think that's going to inform some of the other comments about consent and policy, which is no, they're not intended to be mandatory. It's all about optimization, right? Now, John, feel free to chime in, but currently it's not a mandatory. And so the server is required to be able to handle the case where the client persists. Now, if it's overloaded, it's of course free to simply close the connection. But it isn't mandatory because we don't have servers dictate policy to clients in this working group.
Agreed.
John, I saw you turned on your mic. Oh, there you
yeah,
are.
there's also backwards compatibility of, no, that I would say that it is not mandatory. This is for better performance, but it is not a requirement for the clients at all.
Great, thank you. Eric, please.
Yeah, so you obviously HTTP has similar use cases that exist, and those are being
worked on there, you call them out as alternative proposals and say they don't quite work here, but at the same time HTTP is still HTTP and those will still exist for encrypted DNS over HTTP. So how do you see them interacting together? Are you proposing we ban using those mechanisms like redirect and alternate service for DNS servers operating on DNS over HTTPS? Do you see them just being able to use both? Which in that case, do they have the problem of we might have two completely different redirects and we might have the ambiguity case of inconsistent behavior if one client follows one and the other follows the other? Do we mandate specific mechanisms for you must follow this one if you get both? What is the interaction story here? Do you have the vision for that, or is it something that needs to be developed?
The latter, and so we can go entirely into Tommy opinion land now, but I really don't want to do both, right? Per query overhead on redirect is something I don't ever want to support, because I'm configured to use a resolver, right? It's a little different from HTTP where each resource is located somewhere else. A recursive resolver is supposed to answer all my questions. And so no, I don't want them to coexist. I don't want to use 300 at all when I'm using DO.
But at the same time, I'm thinking for some clients that may only use DNS over HTTPS for their encrypted DNS mechanism, some servers that only use that, they may be looking at saying, hey, we only care about HTTP. HTTP is a mechanism that can solve these problems. We should just solve it there. Even if nothing perfectly exists to solve our use cases there today, let's add it to HTTP to solve our use cases. What's motivating them to not say we just want to solve this in HTTP, and then we have this problem of some servers will be trying to do some to solve it for some cases, and we have that interaction. So I feel like we can't just say, this won't exist. There's going to be the interaction. I think we need to solve it somehow. And that gets into the question of maybe some people might say, we don't want this. But at the same time, obviously, others in this room will say we want stuff besides DNS over HTTPS. So that's not going to be the solution either. So,
and John, you want to respond to that?
Yeah, I guess I would say that it seems like a more universal solution would be the preferred choice. I agree that in fact, there are going to be probably multiple different ways of doing this in a variety of the different subprotocols in DNS. Why wouldn't you just pick the one?
More universal solution is especially tricky here because, yes, I agree more universal is better, but is more universal as in solving more DNS cases, or more universal as in HTTP is a much bigger thing than DNS, and so if that fits within your scenario, that's more universal. So while more universal is a good goal to go for, it's not really clear in this case which one is more universal. So I think we still end up with this situation where it's tricky to make decisions. Anyway, that's all I've got.
Okay. Thank you, Eric. Welcome back, Ben.
Hi, sir. My connection to MeetEcho has been unstable. So Tommy mentioned earlier that Apple has a bootstrap process that repeats some of the discovery queries through the encrypted channel to see if the resolver has an opinion about its own location that's different from the bootstrap resolver's opinion. Chrome actually also has a version of that. This draft is also essentially proposing a bootstrap mechanism. So I think that we're onto something here. We should we should have a document that talks about bootstrap. But this specific proposal, I don't like in the details because I think it's actually insecure. Remember that DDR was deployed later than encrypted DNS. So imagine that I am connected to an encrypted DNS resolver that doesn't know about DDR. If I send this discovery query, that discovery query can totally pass all the way through that resolver and out into the public internet over UDP, at which point anybody on the network can inject and synthesize a response that claims to be the correct answer for _DNS.resolver.arpa. And since in this proposal that response can overwrite the trust anchor for my resolver, I can be redirected to do do.attacker.example via this mechanism, and then validate the certificate for do.attacker.example.
So to summarize, go ahead. Sorry.
So this is one example of more generally why I really don't like the pattern of the server sends us one message and that's enough to tell the client, okay, we're going to change our certificate validation.
So in summary, really the concern being non-compliance resolver.arpa recursives blindly handing that trust decision upstream, right?
So that's one example. That's sort of one example of a more general problem here, which is something we've talked about a lot in the past, which is a transient to persistent attack upgrade. So if I can transiently compromise your, if I can essentially inject one response somehow in any way to this discovery name, I can change the validation point used by the client, and from then on have, at least for the length of the TTL, get them to use my resolver instead of the one they intended to.
So the first,
I want to jump in here for a second, Chair.
Please.
It seems like we're having a really awesome design discussion going on here, and it says to me there's a lot of energy and interest in this topic, as Ben pointed out. Similar parallel thinking is going on. Maybe, as a suggestion, you guys should maybe step back, go have a coffee virtually with Ben remote, and iterate on a next generation. But it does seem like there's interest, so that's really awesome. But does it seem reasonable?
Yeah, oh yeah, totally.
Okay.
A lot of good list discussion here. Eric, please.
Yeah, it was basically what Glenn was saying. I like to see interaction on a draft that has been posted 4 hours ago, right? So please, next time, post it the week before 4-00, right? Again, nice discussion. I think interesting work, but I need to say it, right?
That sounded like he definitely had his AD hat on there.
Yeah, a little bit.
And I'll say that we looked at the draft, and we had a discussion. We think it fits within the group, so you've got a home to do it in. So make with the doing.
Okay.
Mr. Nygren, please. Close the queue.
Changes. I think a bunch of the challenges with the original alt service header had been around some of these issues that Ben was referring to around like what happens if you get a single response back and you hold on to it for too long and then things change, like which CDN was being used changed, or the trust of the person you originally got it from changed. So there's a number of these things we've learned from in the alt service side, which is why we're looking at the alt service BIS directions, and some of those discussions might help inform design here.
Agreed, and I appreciate the pointer because that's something that I'm currently involved in, so we'll definitely be discussing. I will point out, and I promise not to rabbit hole in this, but that's something where the upstream case makes perfect sense, and I hadn't considered that. The transient attacker case is interesting because once we're talking about the ability to change a query response, I don't see that it matters what you queried for name-wise if the result is the same. But it's certainly something that obviously needs more discussion.
Great. Thank you, Tommy.
Thank you, Tom. Okay, gonna switch over to you. You want to come up to the mic? Share screen.
Should start AOB. I named it. So what just happened? Where's Safari?
Whoa, Safari, what have you done?
His slide should be in the. Yeah. Yeah.
So while we are setting the slides, obviously the next draft, if I think that's the right one you are talking about, is not for adoption, right, in this group, simply for education and for information.
Yeah.
Okay, you're up.
Yeah, that's right. I mean, this draft is we wanted more comments and feedback on this draft, and we need to find a working group for this, and if there is any interest in implementing this in the first place. But this draft we started writing this proposal when we saw the comments from ISEC review, and we realized that there are security issues that need to be fixed, right? And we thought we'll just highlight the problems and some potential solutions that would address those concerns that were raised, right? Next slide, please. Yeah, so the problem statement is quite clear that one of the main reasons is that .NX is not widely deployed in several networks, Evil twin is a very prevalent attack that you see, that an attacker emulates the actual network that you're trying to connect to. The attacker uses the same SSID, and the PSK is probably leaked to the attacker because your device is compromised, or the PSK is kept on a board wherever you can see and pick it up, right? Coffee shops use PSK, which is put on a QR code. Home networks use PSKs. Small office home networks use PSKs all the time. And we have seen evil twin attacks happen in those kind of networks. And how do you address the scenario that user believes that user is trusting the network and the DNS resolver it's providing and the DNS queries are encrypted to it, but you're actually connecting to an attacker's network? Next slide. Next slide, please.
It's
Okay. Okay. That's the same problem if you're using opportunistic wireless encryption where there is no PSK. It uses Diffie-Hellman to basically mutually establish a shared key and then encrypt them, do the WPA pre-handshake. We saw similar problems in where as part of the supply chain attacks, there is a possibility that your SIM card could be compromised and the attacker could get access to your pre-shared key. And that's one of the reasons we see fast forward secrecy EPK extension being discussed in the EMU working group. So with all that, we were wondering, is there a potential way we can address these threats without going back to the Wi-Fi alliance, right? Next slide, please.
It takes a second.
Yeah, no problem.
There you go.
Yeah, so since we are learning and network advertised encrypted DNS server, we were wondering whether we could use that to help identify whether it's an evil twin or not. So we figured out a way where if you're using the traditional WPA2 or WPA3, whether you want to rely on the SSID names. If you don't rely, then we figured out a trust on first use so that you can on the second connection to the network, you would check if the DNS server identity has changed. If you're relying on the SSID names, you don't have to rely on TOFU. And then Ben had a comment that, hey, you could use that technique as well in networks which use IETF, and we updated the draft to address that comment. Next slide. So it's trust on first use is you either use DNR or DDR to discover the resolver. Then you create a fingerprint for the network. You basically use the SSID hash of the pre-shared key that's being used, the discovery method being used, and the identity of the resolver that's being discovered. For instance, in this case, if it's DNR, it's the FQDN. If it is DDR, it's the IP address. So you basically create a fingerprint of the network using the discovered encrypted resolver. And next slide, please. So once you create this fingerprint in the first connection to the network, on subsequent connections, you check if the DNS server identity matches or it doesn't match. If it doesn't match, it gives a hint that it's probably an evil twin which is trying to look at your DNS or even modify your DNS responses. Next slide, yeah. Yeah, the other one was obviously to use an SSID name which matches the subject alt name within the DNS server certificate. It would probably work for public Wi-Fi hotspots which don't have anything private to change, and they could probably have something like an example that we listed here, but may not be a viable option for home networks where we don't want to change and typical home admin to go and change the SSID name, and maybe it starts revealing some privacy PII related information in the SSID related to probably the router who has given this, who has assigned this FQDN to the home router, or it could be the security vendor who's managing this home router who has given an FQDN to the home router. So it may work, it may not work in certain deployments. Next slide, please. Yeah, the alternative was like if there are networks which already do IETF, then it works perfectly in those cases that the SSID name has to match the server certificate subject alt name. This would be pretty useful for networks where endpoints are not being managed by the MDM. ETLS allows a mode where client certificate authentication is not mandatory, for example, for emergency services, where only server side validation is required. In those cases, the match would be quite useful, and it would also be useful during the device registration process, where the device doesn't trust the network and device is kept in a quarantine to get its credentials during that process, for the device to know that it's indeed getting the configuration profile from the right network that it is supposed to attach to.
Next slide.
Next slide, yeah. Sorry. Yeah, I mean, does it solve all the threat vectors? Yes, it solves threat vectors to a great extent. For example, an attacker could still use the same DNS server as the legitimate network. For instance, if the legitimate network is using a public resolver, it would still advertise saying that I'm going to use the same network, but it definitely reduces the capability of the attacker. It would not have access to the DNS messages, and in near future, when clients start using TLS 1.3 and encrypted client hello, the capability of the attacker to see what domains the endpoint is visiting will be reduced dramatically. And the attacker will not be able to, for instance, remove the ECH keys from the DNS records to cause the client to downgrade to a non-ECH mode. So these are some of the advantages that we see, and we would like to have feedback from the working group. And if there is any interest to implement it and better ways of solving that, so we would like to hear from people on how we take this forward.
No, well,
So the queue was closed before, because I've got it all in this one workstation. I'll flip over and open up the queue, you lose your slides.
Right.
So as soon as we're done, I'll open the queue.
Right. Which, well, we're done now.
Okay.
So, and I saw Ted, I don't know whether you dropped out of the queue again because of the same laptop lid closing issue, or? No, I just put it in the chat instead. Okay. And I saw Ben popped up, but right now David is the active one, so.
And the queue is open.
Hi.
Yeah.
Wow, sorry, really have to eat the mic. David Skenazy, internet architecture enthusiast. This feels like a non-trivial solution. Like, this feels like it has quite a bit of complexity to solve a very small part of the problem space. Like, I totally agree with you on the evil twin attack, and in some cases that's a problem. In many cases it's not. Like, if I connect to a coffee shop, I don't care. I have HTTPS that takes care of everything that I personally do on that, and then I have my mask thing for anything else. So what I would suggest is, if you're worried about this problem, I would solve it at a more holistic level. So perhaps at the 802.11 layer, or something different. But this feels like all of this tofu infrastructure seems smart, seems good. But once we have all of that and we're saving all that state and we're checking certificates and we've done all this, just protect all the traffic. Don't do this just for DNS. It's not worth the effort.
Sure. And the reason for doing DNS was that because endpoints would discover the encrypted resolver they're attaching to the network. If they're using a pre-configured resolver, this is not an issue at all, right? This is when you're using DNR, DDR, you don't have a pre-configured resolver and you're using the local resolver to discover these encrypted resolvers. You want to make sure the comment that we got was basically it gives a false sense of security that you're assuming you're connecting to my home network, but you may be connecting to an evil twin, which is like sitting in a van watching all my DNS traffic, right? So for that, right, we are looking for ways that are practical enough, right, and ways that could be implemented rather than going to 802.11. I've seen those discussions happening in the past, and they're not changing the way they're doing it, and then it's becoming quite difficult, right? I mean, whatever the solution could be, if it's practical enough and deployable, it solves a problem for the implementations which are using DNR and DDR.
Absolutely. And I'll just say one quick thing before I go sit down is, I think you're going to run into the same problem that is the reason that IEEE hasn't fixed this for Wi-Fi, because they're no less smart than we are, is that in the like this, what you're saying is not for enterprise networks. They have 802.1x. This is for the mom and pop coffee shop, where in practice, all they did is they bought the router and they got the neighbor's kid to configure a name and a password. If that router breaks because they bought one from Target for 20 bucks, they're going to go tell them, can you put the same thing on the next router? And then you're all sorts of screwed because your users can't connect because you have some keys that were in the other one. Otherwise, they would have done this tofu at that layer. So this feels like a more complex problem with a much bigger solution.
Thank you.
Thank you, David. Ben, please.
Hi. So I agree that it's not going to be so easy to deploy something like this, but I still think it's fun. I think it's worth a try. You know, it kind of doesn't cost us anything. I think that as an experimental draft, you know, it has potential. However, I think that the only authentication layer that makes sense here is IETF, and I don't think that connecting this to the name of the local resolver makes any sense here. It's essentially conflating the identity of the network with the identity of some DNS servers that the network is mentioning to people who are on the network. My local network announces Google's DNS servers on my home network. Like, does that mean that I need to name my wireless network DNS.Google? Because that's going to be a very strange name for my home wireless network. But if I could just say that the name of my wireless network is a domain that I control and prove ownership of that over IETF, then I can do DNR over DHCP with DHCP guard on the local network and actually have a fully secured chain where each link in the chain is authenticated or secured by the appropriate mechanism. So I think this should just link the SSID to the network association, and from then on, local relevant mechanisms can apply, which means it's not an ADD problem. It's not that far from dance, actually, if you are looking for a home for it.
Yeah, thanks, Ben. Yeah.
Okay, and that was it. And
Thank
I
you.
believe we're at Glenn's wrap up now.
Yeah, I will say that we've talked about this particular draft, the question with Ben of where does it fit? We talked with Eric and Taylor and myself, and we don't think it fits an ADD, but it's good.
Yeah, we'll figure
it
out.
was a place to start.
Yeah.
Well, that's the wrap up essentially. I mean, we've done our drafts, we've done our thing, we have things in the process for publishing. I think we're in good shape, and I think we've been successful at IETF115 to have a very productive ADD session. So thank you very much for coming in, and the people who are at home, thank you for joining. The one thing I will say is if you are in the room and you have not gone into the local tool to sort of say, I'm here, that's how we do the blue sheets now. So go in there so that you get your name recorded in the blue sheets on the local tool. It's off the agenda on the IETF site, or you could do that.
And it does matter for a couple of different reasons, notably for logistics for the future, but also for historical. Sometimes they need to be back referenced about who was actually present.
And we also get an accurate count for next time. For
Well,
how big
that's
a
the
room we need
logistics
for
part.
ADD.
Yeah. And thank you again to Liman for being our scribe. And we're out.
We're out.
Okay. I don't know how to turn that mic off. Yeah.
I don't know.
Other than.
I don't know. Because then I have to be, I gotta fix. Like you breaking the chair.
I broke a chair?
Well, no,
Oh, no.
Your desk.
It's clearly meant to be a fiddle toy.
No, it's the internet, right? It's the Lego. All right, I'm gonna walk away from the hot mic.
Yeah.
surprises everyone. It's water, so I have to subscribe to the flight. It's my iPad, everything I need is like and this fits into it. It's a regular bottle. It's the same size as a bottle of wine. Yeah, when I was a regular bottle. Yes. Now that's actually one thing I noticed. It's probably too much wine. They make a smaller wine.
So is that it then? Thanks for sharing.
Yeah, yeah, yeah.
I don't do physics, so I have to do like I can't this week because I'm crazy busy. The rest of the year, I kind of just have to review it. That's helpful. But if it's a huge school, like you can do your thing. Or you want something on the list, I can actually. Is there a deadline this week or can this happen?